Today's show is brought to you by Folk Consulting Services. Folk Consulting Services has more than 15 years of experience and is a high-caliber, industry-leading services provider of application performance testing services, monitoring, and management with a strong background in software quality assurance. Folk Consulting has the greatest consultants in the world, and they love growing their customer-focused relationships. Find out more at www.folkconsulting, that's F-O-U-L-K, consulting.com.
How does garbage collection impact my
Why
daily
can't I have dessert for breakfast?
Should I use percentiles or averages?
Why do clocks help you?
What's up with the number 42? What is the n+1 problem? Can exceptions ever be useful?
Why don't developers like me?
Why does grandma smell funny?
Ask Perf Bites.
Hello and welcome everybody to another episode of Ask Perf Bites. I'm your host, Brian Wilson, and I can't believe it took me this long to find out about Gravity Falls. This episode's question comes from Trisha. Trisha asked Perf Bites, how does caching improve performance, and what do I need to know about testing it properly? Thank you for your question, Trisha. To help us answer this question, I'd like to introduce the host of News of the Damned, and I think the voice of Satan, James Pulley. Hi, James.
Hi, Brian. How's your day going?
Pretty well, pretty good. I always never know which one to say. When people ask, how are you? I say, I'm good. And they say, I'm well. And I'm like, you grammar.
Yeah. And actually, I
I'm
really do need to clarify that whole voice on the intro to News of the Damned. It is not me. Mark Tomlinson got that voiceover. He and I talk about this all the time. I have no idea how he got it. I don't know what he needed to sign. I have always told him I'm concerned for his immortal soul over this thing.
Maybe he visited some crossroads at
where
was that with the guitar player?
He just looks at me and he's like, no biggie. And I'm like, Mark, I think it is a biggie, one of us is wrong.
For the show.
And,
it's all for the show.
I hope he doesn't pay a high price for it.
Well, I think if you've ever seen him, I think he has paid a high price already. If you ever spend any time around him. We love you, Mark.
So News of the Damned is our Three Stooges or Slip and Fall show. We take a look at items that have failed in production, and we look at public sources of data for information about the patterns that have led to the failure. And then the idea there being is that you can take the pattern and you can go and look at the items that you're working on and see if the pattern does apply. Is there a lesson that you can learn from someone else's failure that you can apply to your current application under test and hopefully avoid a similar fate? At least that's the goal. Maybe we're successful, but that's the goal, at least.
And I think if there's anybody in sales, if you want to be an ambulance chaser for performance, following News of the Damned on Twitter is very good because you get to see a list daily, basically, of all these companies and organizations that are having performance issues. So again, if you want to have that, ambulance chaser mentality, it's a great thing to follow there. You've been very busy, actually. There's been a lot going on lately.
Over the last 2 weeks, just
shift
related to COVID-19, there have been over 130 failures in government websites.
Right, yeah, because obviously if the private sector is not prepared for all this change, the government sector is going to be even less prepared.
Yeah, it's
not that the government sector hasn't. We discussed this before. Some parts of the government sector have made some great strides in agility and cool things they've put out, but a lot of it is still so much left behind because of so many just ingrained ways, the things they've run. So yeah, it's interesting to see it all, and hopefully people are out there learning from it. Hopefully it's not just, hey, let's look at the accident on the side of the road, but let's figure out how not to get into that accident in the first place.
Exactly. And there are some patterns there. You can go back and listen to the last 2 episodes of News of the Damned. We cover some of those. But you know what? That is a topic for a different day because we want to get to Trisha's question about cache.
Hey, I'm the host. I'm supposed to be moving it on. Kidding. So again, there's 2 parts of this question, right? And I think there are many layers, right? The question dealt with caching. So how can you improve performance with cache, which is very, very broad, and there's a bunch of layers that we're going to go into, a lot of them. And then part of the other side that is how can we take these into account when designing a load or performance test, and what considerations need to be taken, maybe what setups or what steps do need to be applied in order to test them correctly. Because again, and I mentioned this during our pre-talk before our show, this doesn't give anything in the way for the show, because this is like a super beginner basic one. But obviously, if you take the example of if you're going to be testing a search function in your load test, and you are going to be testing search terms, if those results are cached, if you use the same 50 search terms, you're not going to be testing anything, because it's always going to be coming back immediately from that cache. If you use all random, hundreds of thousands of random words, you're never going to be hitting the cache. So the idea of finding that balance, right? So we will try to, as we talk about some of these different cache strategies, how testing strategies can be applied to exercise or make sure they're working. So wherever we can fit them in, we'll try to do that as well. So James, let's start from the bottom, right? So when we think about caching, a lot of people probably initially think about browser cache and things on the front end or CDNs, but caching really starts all the way down at the bottom. Database layer can go through. Let's take that bottom up approach. I think that's going to be where the fun stuff is.
So let's ground what is a cache.
Yeah,
because I think that'll help a lot. So a cache is a store of some value which is less expensive to access than some other area or some other larger store of value. And you've probably seen this in literature. We might have a cache of weapons stored close to the front line of a conflict because it's easier to access them than go all the way back to the supply depot. We might have, if you're in the Disney universe, you might have if you're Scrooge McDuck, you might have a cache of gold coins sitting in your desk drawer because it's cheaper there than to go all the way down to the vault, for an average expense, just grab some from the desk drawer or something. But in the data world, it's a store of data which is less expensive to access than going to the original source.
Right.
And when we look at our finite resource pool, our CPU disk memory network, each one of those has an expense associated with it. For instance, network is the most expensive.
Yep.
Because you leave the bus and, your reduced speed. Disk is the next most expensive, then memory, then CPU. So the closer I can get the data to where it's being used, the faster or more responsive my app. And we can talk about CPU architectures, and CPUs have these horribly fast, memory caches that are on the die, and they're much faster than what's across the bus. But on a practical basis, most of the time you're looking at caches for disk activity or caches against network activity, because those are much more expensive.
Right. And one thing I want to point out too, that there is crossover and relationships between, let's call them the four elements that you talk about: CPU, disk, network, and memory. Because even if you talk about network, right, you have to open a connection.
Yep.
And where does that connection get held into? In memory.
Yes, it does.
Right. So all of these, they're not independent too. So just as we go through this conversation, dear listeners, keep in mind, there's always, nothing is ever free, whether or not we're not even talking in terms of running in the cloud for once. But, if you are establishing a network connection, that's going to consume some memory. So just one little example. Anyhow, let's get on with the show. So where's the best place to start?
Yeah, and that's where a cache connection pool comes into play for lower expense.
So where do you want to start? Do you want to start on database concept, or is there some lower level? I know you kind of mentioned the processor, but I think that's sort of beyond. That's getting into really that's edge case. That's kind of edge case.
That's really getting into the weeds on that one. Yeah. Let's start at the database cache. So you can think about a query, and let's make it really easy. Select states from country where country equal USA. And that gives us a list of 50 states, and maybe it includes territories, Puerto Rico and Guam and Siam and places like that. But it gives us a finite response. Well, what if every connection that comes into the database has to make that query at some point? That is, I arrive, I'm seeding an interface because I'm in the United States and I have a drop-down list box associated with states. And so I'm going to make that query. And then the person next to me is going to make the same query, and the person next to them is going to make the same query. Well, gee, maybe we could pick up some efficiencies if we didn't always have to go to disk and pull that information off every single time. Well, that's where the query cache comes into play on the database. It stores information for a period of time, and it will age out of the cache if it's not requested again. But the ideal would be, hey, we have it in the cache long enough so someone else who comes along can make the same query. And it's like, hey, it's in the query cache. Let me give it to you from RAM, because RAM is so much faster than going to disk, particularly if it's an expensive query of some nature. Yeah, I gave you a really simple one. But let's say it's it's a million rows of something, and it's not index optimized, and you do a table scan, and all sorts of bad things. But you get the result in the RAM. Once it's there, as long as we can leverage it, hey, we pick up orders of magnitude because RAM is so much faster than disk, and we can continue this idea of a faster location as we move through an architecture. As we move outside of a database, we might have something like Memcache, which caches a query there. Yeah.
Before you go there, because I think Memcache is really important, one thing I think it's important to bring up on the database side, right? Because you gave, again, very simple example states, they're not going to change, right, anytime soon, right? So it's very static data. So it makes sense. Yeah, static data, put it into at least the database cache at a minimum. But another way you can think about the application as well, all these caches can have timings and expirations, right? So let's say you mentioned a complex query, right? Now, the first thing a person might think, if it's a complex query, how likely is that to be repeated? But let's say you're working with a complex data set, and maybe you're going to do a filter on it and then refresh your data set to have it display differently or something else, and if you're not going to be caching it or storing it on the client side, although that's a somewhat unique type of a query, a complex query, if the typical workflow is going to have a person use that data set several times, although it might consume a little bit more memory because it's a larger data set, it might still make sense to put that into the query cache, because that person might be reaccessing that same data set over and over again for the duration of whatever the business process might be. So if you have a business process that takes 15 minutes, just putting it into people's minds, like there are really simple, easy examples, but then there's also, well, how long is this data set going to be reused, and how many times might they go back and grab that same data? So you can put it in there, you can put a timer on it and have it blow out, and that's still going to save you a lot. Right?
And realistically, if from the client you're asking for the same data over and over again, you're much better off storing it at the client for that reuse rather than going and re-requesting it. But I think your question on data complexity and query complexity has some impact on performance testing as well.
Right.
Because if let's say I have a test of a financial system, and I'm constantly looking at accounts. I sign in with a different name, and that brings up a different account. If I don't have enough complexity in my data set for my test, and I have a database which has a very large amount of RAM associated with it, well, if there's no really need to purge anything from cache because I'm not constantly oversubscribing the available cache window, it's just simply going to hold that data in there for as long as possible. And because I have a small amount of data that I'm using in my test, I'm going to be constantly re-hitting it. So its aging out is not going to take place as well. So I can artificially distort the performance of my system by having that data that's sitting in memory. I can recall a performance test that was done many years ago where company A was asking me to audit a test for company B because they were evaluating company B's technology.
Right.
And company B decided they were going to make all their data the same across all accounts. So it was impossible to tell whether they were actually going and getting new data or if it was pulling from cache. Mm-hmm. And therefore the risk was substantially high that the performance of the application under test was actually distorted faster than it would have been normally in production. And therefore the risk of purchasing that company was higher in that case.
Great. That was a great example. And, going back to where we were going to move then, right? If you were going to take let's continue with the 50 states example, because I think this one plays well into moving where that cache sits, right? If we're going to the database query cache every time to get that 50 states, well, we're still running a database hop. I mean, not a database, but a network connection.
Absolutely.
To grab that very static data that we're going to be using over and over again. So the question is then, why don't you just move it one layer up? And I believe this is where you were going to talk about Memcache, right? Why don't you first give a little explanation of Memcache and, their similar kind of technologies, and then let's talk about that one.
Yeah, so think of Memcache as basically an in-memory only type of item that has a hashed index and is a bunch of name-value pairs. And those name-value pairs can be seeded from a lot of different locations. They don't have to be from a database, but they can be. They can be coming from a file. They could be coming from any number of other sources. But the benefit here is that it's an in-memory and it's highly indexed, so it's very fast to access. And this data could be stored in a geographically closer location than the database. And when I say geographically closer, that doesn't mean that it has to be a difference of a state. It could be simply the difference of 4 or 5 network hops on your own local network or on your own campus. But the fact is that it's closer and it's in memory, it's always going to be an order of magnitude faster.
And if you think about traditional databases, right? Let's not talk about big data databases, but if you think about your traditional databases, that's usually one large server sitting somewhere.
Sure.
Whereas if you have, let's say the tier right above that, that's running the query, let's say you have 5 instances of those. Well, the nice thing about Memcache and, there's a bunch of different kinds of brands and technologies of Memcache is that you can have a distributed and shared Memcache across all 5 of those. So for the price of maybe 1 gig of memory or whatever it might be on each of those boxes, all that data is stored locally on that box. So besides getting rid of the hop, you're also not going to another single box that might be storing that. You could have it all local. And as you mentioned, it doesn't have to be coming from the database. It can come from any source. And if anybody thinks about their swap file, I remember going back in the early days of my when I used to still use a Windows machine, I'd always set my swap file to be, I think, 2 times the size of my memory on the disk.
Yeah.
So I think that was the general, somewhere around there was the general idea. So because, again, if you're putting it into memory, it's a heck of a lot cheaper and a heck of a lot faster than going back to disk. So these Memcache things are a really, really great way to pull it off your database, pull it off the file, put it in memory, and you can also distribute that so that it's local to every process or instance of the service that needs it.
Exactly.
Right.
So it's really close. If you have it on the same box where it's going to be needed, it's even closer. It's in memory. So you avoid a network hop altogether. And once again, we fulfilled our goal of having the data that we need to access on a lower cost basis than the original data, which is, get it faster, get it closer, and therefore the whole system responds better.
Now, in terms of testing, I think this is, there's obviously some stuff we could have discussed with the query cache, but this is where we start getting into a little bit more risk, right? And I almost feel like, I guess risk could be described in a lot of ways, right? But if you're talking about in-memory storage, A couple things can happen, right? When you first start up the system, you're going to have nothing in memory. So until you build that cache up in that in-memory, caching system, things are going to be going back to the database. Things are going to be slower. So you have to, that's a scenario you have to consider in your performance test, because at some point that might be happening in your system, or one or two or all of the nodes might just lose that cache, right? If that cache goes down, if some event happens that blows it out of the clears it out, while you're running in the middle of your day in production, you still have to be able to perform. So when you're thinking about the tests that you're going to run, yes, you're going to want to run the sunny day test, but you're going to want to run some of these scenarios where you're pulling this cache, where you're blowing it out. But also even with the data sets that you use, and this is something I learned the hard way back, is make sure it's a realistic data set. Things that'll be cached versus things that won't be cached, because in reality, some will be and some won't be, right? So you want that balance.
Yeah, one thing that I found is that sometimes you can simply reduce the cache size. If your data complexity is not as high as it should be, let's say you have 1/5 the data complexity of what you would have in production, why not reduce your cache size to 1/5 so you actually do get the benefits of a least recently used element aging out of the cache, right? And so the query actually has to be completed and the cache reseeded. So just keep that in mind from a strategy perspective. Is you can either reduce the size of the cache, you can increase your data complexity, but ultimately you want to get the exercise on the most expensive pieces of the system, because that's where you're going to get kind of the worst performance and see what is going to occur naturally in production.
Right. That's when COVID hits, as the government sites are going through, the things are going to start failing. And this is
yes. When you want to go file for unemployment and everything starts to melt down. Yeah.
And just to do a quick tie-in over here, so you obviously know Andy Grabner. He and I on the Peer Performance Podcast have been having some guests on speaking about chaos testing. And to me, I think chaos testing and load performance testing are cousins, right? It's all very scientifically executed, scientifically set up. Here's a theory. Here's what we want to test. What do we do to, what plug do we pull to do whatever? And in a way, when we talk about, testing the bounds of your Memcache, right? This is touching upon chaos testing. It's going into that realm. So they're very, very similar. And to anybody who's, interested in that idea, definitely look into chaos testing, chaos engineering, because it is a familiar term.
Well, when you think of a performance test, we are ordered chaos within certain boundaries.
Very good. Yeah. Good way of saying it. So it's a nice way to expand if you're looking to expand your skills, but it's somewhat related to this. All right. So where do we go from Memcache?
So if we expand out from Memcache, we can go to the app server or the web server. Probably the web server is the easier one to discuss. Because even in a context of where we don't have a database on the back end and it's a really static site for a web server actually has a request cache. Right. So if you are requesting the same file over and over again from different users, that will wind up in the request cache, cached off of the drive locally, and then when it's requested, it'll come from memory to the end user. Now it'll be passed across the network. Network is expensive, yes, but it doesn't have to be pulled from disk every single time. And there is an expense associated with disk. Once again, it's that we're getting it from the least cost location from the original, which is memory is faster than disk. So if we can get it from there, hey, we're better off.
And if you think this goes back to my days when I was at WebMD, we had a content management system, right? If you think about an informational site like WebMD, static, the content is very static, right? There's going to be some updates. So, COVID breaks out, obviously there's going to be, a bunch of updates on the main page. But if you're looking up, any information on that site, it's pretty static. So
if you're going through the symptoms list to see if you have MS or cancer,
and it tells and everything tells you have cancer instead, or just look up drug interactions,
or something like that.
Almost any of the page, any kind of content, pure content type of site is very static. However, on the back end, you have the content managers who are making little tweaks and updates. And in this example you're talking about, I saw this a lot at, in that job where, in order to get the page, right, the first time the page gets hit, it has to get created. So it goes back to the content management system, finds all the elements that need to be on the page. Then it has to actually grab them from the database, right? It has to construct the page. Then it's going to go ahead and put it in memory or on disk somewhere up in the cache, right? Until it expires, or maybe there's a rule every 24 hours, check for a new one unless you get, a notice that there's a new component. So that's a great example, I think, of that web server caching, because if you have a page that's pretty static, there's no need to go further down the line to pull.
You
all
can
the
even
elements.
use an e-commerce site as an example. Getting to your templating example, might be using something like a handlebars and mustaches type of templating system running in Java. It constructs the page. The page has a cache timeout in the system before it has to be reconstructed again. It goes to the web server. It's held there, maybe on a local drive for a period of time. And then if it's requested, it's moved into memory. You have really interesting dynamics here with, say, something like a spot sale. I have 5,000 pet rocks available at $2 for the next hour. And it's like, okay, so the first person who requests, hits that page, the pet rock page is created. Hopefully it's been created and pre-cached, before the spot sale occurs. But, we'll give them benefit of the doubt that they haven't done that. It comes to the web server. It then gets pulled into memory, and then all of the cacazillion people who come and want a pet rock now hit it out of RAM at that point, ideally.
Right.
That's how it should work.
And the same thing goes with like images, CSS files, JavaScript files. Those, and I've seen this plenty of times, using the APM tools. Sometimes you'll see those queries go all the way back to the database to generate or to identify where that image is.
I know that's just crazy to dynamically build a CSS file every single time. That's just nuts.
Well, I mean, and usually it's not, hopefully, but when you start seeing it happening a lot, that's when you start saying, what's going on here? And that's usually a good sign that they're not caching these things. Now, let's think about this one before we go to the next layer. For testing, what should be done on testing for this? Because this is a little bit less. Seems like there's a little bit less risk than with like something like Memcache, right? Because Memcache is having such sensitive data. A lot of these are static resources. But again, what would we want to do? We want to maybe do some tests where we do clear out that cache maybe, and maybe filling. Is it the same things, or would you take any sort of different approach to make sure that this is working correctly?
This is one of the reasons why you don't automatically go from 0 to 100% at the start of your test, why you have a warm-up period where you're getting the system exercise, you're getting these cache tunnels filled up, you're propagating your data through the system, and then you get to your time under test, usually after a 20 or 30 minute ramp up, and then you're actually collecting samples during that period. Right. Otherwise, if you go from 0 to 100 immediately, I like to call that the teetotaler and the vodka problem. You take a teetotaler and a thimble and a bottle of vodka, and you combine a thimbleful at a time. You might actually survive. If you take a teetotaler and a bottle of vodka and combine them all at once, you'll probably get system collapse. Yeah. In this case.
Now that does bring up the idea or the question of, well, what if we want to test certain scenarios, crisis scenarios? We've got to pull a server out of rotation, reboot it, push something in, and then toss it right back on in. But, and I want to get your opinion on this, but my opinion on that is, that is a very special test case that you're going to be running. And you don't necessarily even want to do it as a 100% on, because you'd have to first study and understand how the system is going to start diverting traffic to it, what that rate is, and then try to mimic that in order to do the test properly. It's not just going to be an 100% hose on. I mean, it could be, but
yeah, there's a whole process to that, because you have to go to the load balancer, take it out of the balance group, wait for the load to dissipate off of it, then take it down, bring it back up, add it to the group. So it's not as simple as It's more of a functional test under a high load rather than a load test.
Yeah, and even when you put it back in the balancer, it's not like it's going to get 100% of the traffic right then, because there's other servers that are going to be, it's going to be balanced.
Sure.
So there's still going to be a ramp curve. And I think if you're going to do one of those tests, you need to study what that would look like in production so that you can mimic that curve, not just do 100% on. And again, this comes back, in a lot of other episodes, it always comes back to understanding what you're trying to test and figuring out what that characteristic looks like and find out what to do. All right, so let's move on, right? Because obviously you can have the stuff sitting on your server, but your server might be in Poughkeepsie and your customer might be in Portland.
Oh, that's a pretty good distance.
Yeah.
This brings us to the cache model that most people are familiar with or have heard about, which is the content distribution network. And it is key here that we educate the content delivery network on what types of files can be cached and for how long. And we educate that CDN through our cache headers that we set. Either we set them programmatically or we set them at the server. But that is what the CDN layer uses in order to understand, can I actually hold a copy of this file and for how long before I need to check back in to see if there's another copy. We just had a great example of this on the last News of the Dam show, which is the site for how much toilet paper do you need to survive the apocalypse. And
all of it.
And the entire site was static except for the front page. The front page was marked as dynamic. So when that site caught fire, everybody went to the site to download it, and the site was calculating a different amount of toilet paper rolls for everybody when it came back, and it just simply overloaded the server and fell over.
Yeah.
So but all of the supporting JavaScript files, style sheets, everything else was marked as static, and it was cacheable, and it actually did have a CDN solution in front of it. I think it was Fastly that was in front of it.
Okay.
So that gives you an example of you can have a CDN, and the CDN could have the files marked appropriately, but if your front end page is dynamic and it doesn't need to be, you're still going to have pass-through load going to your servers in this case. But so watch your cache headers in that case, and that's usually set in the config file for your web server, or alternatively, you can set it as a developer when you're developing your templates and you're setting your response headers. You can set it there. There are some elements which are cacheable that a lot of people don't think about.
Yeah.
404 is a cacheable event. So if you have a developer who forgets to include an asset, let's say the flag of Outer Fredonia, to go in the little footer.
Yeah.
And, they just forgot to put it in there. You could, in fact, have a custom 404 handler which has a cache header so that constantly doesn't keep getting hit. Or the other one that is really a constant annoyance to web servers is the little icon for your website. That goes on the browser
the
bar.
favicon or something?
Yeah. It's a little .ico reference.
Yeah.
If you got a 404 and a .ico reference, do a custom header, and because otherwise you're going to get a request on every single page for that little custom icon that. The other one is 301 permanent redirect.
Okay.
You can cache those at the CDN, have them auto resolved, so you can avoid a double handshake going back and forth, which is kind of nice.
Yeah, no, I think when it comes to testing with CDNs, it gets really, really interesting for several reasons, right? Because number one, people probably assume, well, we're using a CDN, so I don't need to test that, right? You go back to your load test, your script, and you always have the option to just, hit the main payload, or you're going to download all your resources and you're going to exercise your web server or CDN. And oftentimes, at least in my experience back when I was testing, it was, well, let's not hit the CDN because they don't like it when we do load test against them and they might charge us for it, right? But then again,
that is true.
But one of the reasons they might not like it, right, is because they have a business SLA with you that they have to keep. And, well, you're taking their word that they're going to provide you with the performance
CDN is multi-tenant, so you could impact other people as well.
Right.
And let's face it, there are a lot of bad performance testers out there with no think times and things of that nature.
Yeah.
You could crush a local CDN node. Depending upon where your load generators are, they might hit all one CDN node, whereas your customers are hitting 50 or 60 around the country. You got to take that into account from a design perspective. But what I find really interesting about this is the whole issue of don't download static resources. There's an assumption there. And the assumption is everybody has their cache headers marked correctly so that they're going to be cached by the server, by the CDN. But no one actually tests that. Brian, I got to tell you, the fact that nobody tests it keeps me in business. I mean, it's just that simple. You can actually check that out of your functional test organization as well. Pull the logs, look for 304s, look for constantly re-requests from the same client of the same resource. And that'll tell you if your cache policy is set correctly, assuming that your cache policy is going to be shared, with functional QA and with prod, whether it's effective or not. But somebody needs to ask that question. And today that question is not generally being asked. And then flipping that back around, how do you test with a CDN? You do really need to coordinate well with them to make sure you don't overload the local node. And part of that might be that for those static resources, maybe you're putting a flag on the end of them, such as a question mark T equals and then a 13-digit timestamp as a cache buster. So it doesn't actually hit the CDN node. It just passes straight through for a percentage of them. Working with your CDN provider, they'll have some guidance there. The other options are you can just put your load generators in every Amazon data center and Azure data center and exercise through that way geographically.
And there's also some interesting ways to do it too, because we were just talking with I forget who it was. They were doing a massive scale load test, right? So it was the scenario was it was a kind of like The Voice or one of those kind of shows, and everyone was going to use their app, and there was going to be about 10 million transactions in about 7 minutes for people to vote, and they needed to do a full scale load test on this. And some of the things that came out with it was, yes, number one, for something that big, you do absolutely need to test your CDN because they're probably not prepared for that, right? They're prepared for normal traffic. They know what they have. They know what they get.
Yep.
But one, besides distributing your generators, I believe, and I'd have to go back and listen. It's a pure performance episode coming out. It might be out by the time this airs. I believe if you set up what DNS, where you hit a DNS server, that will give you a different locality, which would then give you service from, basically, instead of putting load generators in, a whole ton of different locations, they were able to trick it with this DNS trick.
Oh, well, that is how CDNs work. Is they work on the DNS basis and passing to the local node. Yeah. So you could confuse it with VPNs. You could confuse it by, I guess, asking for a different, primary DNS that gives you a different local node. So I could see that. That'd be kind of cool.
It's pretty intriguing. Yeah. I want to go back though for a moment. You said something, if I think about, again, my load testing days, this was back with LoadRunner, and most tools you can say simulate browser cache, right? Which would mean that so long as you have a cache time on your CDN elements and everything, and it's done properly, your test will execute it properly as well, because it's going to simulate the browser cache. And if you did download the JavaScript file the first time, second time, it's going to say, oh, I have it in my cache. I'm not going to execute that
Correct.
load step to download the file because we have it, right? But you're talking about the idea you brought up was more of, that's if it's working. You need to tell if it's working. So I just wanted to explore that again, because that's a little bit outside the realm of the performance tester, because I think it really is about analyzing. Well, I don't want to say it's outside the realm of the traditional. It's outside the traditional realm.
It's more on the performance engineering front rather than the performance testing front.
But you're suggesting what we look through certain logs, or how would somebody do that? I just want to touch upon that, because I think that was an intriguing idea, and I want to give the listeners the ability to maybe look into how they might do that.
Sure.
So what is it again you would do?
So there are a couple of places you might look. So you can look in the HTTP request logs on your web server, and if you see an HTTP 304 response, which is not modified, that means the file has been re-requested, and the web server says, oh, you have the latest version. That they're probably using an e-tag, so they're passing an e-tag reference in the header. It's like, oh, yeah, you have the latest version. You don't need to download it again. But you've got that handshake that goes back and forth. That tells you your cache age generally is not long enough. So that's one way to do it.
Okay.
The other way to do it is you can use your HTTP recording log for your performance test tool. If you think of LoadRunner, you can think of the generation log. And in the generation log, we have all of the request headers, and we have all the response headers as well.
Okay.
So in the log, you can see, hey, this file was last changed on September 17th, 2010, and I have a cache age on it of 7,200 seconds. One of these two things doesn't make sense. Either the file is changing and the date timestamp has not been updated, or I can cache this file for a very long period of time beyond just 2 hours in length, and I probably should be doing that.
All right, so after the CDN, we go to
the client.
Yes.
And all of those headers that you've set.
It's a very competitive place.
Yes.
Yeah.
All those headers that you've set in your web server that have educated the CDN on how to hold the request for other users coming in, also in turn educate the downstream client on how long to hold as well. So you have this multiple layers of caching going on, and we can think of a style sheet. Now, let's say the style sheet has an age on it of 2 hours, and it goes to the CDN and it's being held for 2 hours. And then the CDN is set that from whatever the request time is, it's another 2 hours to the client. As long as that style sheet is in play and is constantly being hit in the local cache, we're not going to re-request to see if there's an updated style sheet at least for 2 hours. We're not even going to go to the local CDN node. And so this gets to the ultimate issue of, hey, it's on my local machine. Even if I have to get it from my local hard drive cache, that's still faster than going across the network to the 2-hop distant CDN node, which is still closer than the 14-hop distant website.
Now, this brings up a very interesting, I'd say sometimes mistake. I guess that, again, it all depends on the kind of test somebody's going to be running. Because we just mentioned the idea that the load tools can simulate browser cache.
They can.
Right. So one mistake, one thing I did maybe in my super, super early days, not even thinking, I was just learning how to write a load test or a load script. And I was like, oh, let me log in, again, I'm putting my LoadRunner hat on because that's the only tool I really used at the time. Let me put my login in the init. I'll do my login my log out at the exit thing, and I'll just, in the main body of the test, I'll just repeat all my iterations.
Sure.
Right? So in that case, I believe, unless I'm thinking of my settings wrong though, it's basically like I have the same user logged in and operating over and over and over again. So with every test, even if I'm saying, I want to download the resources and I want to simulate browser cache, it's cached in the virtual user browser. And all those connections that the different users might be going if it was a new user every iteration are not exercising those connections, are not putting that extra stress on the CDN or on the web server because all these elements are being cached. So you really have to look out how you're running your test, how you're setting it up. If you're
correct, there is a checkbox for simulate new user on each iteration,
right,
and that has the effect of busting the cache locally. And while the user is so the cache would be correct in context for the individual user session,
right,
but not across user sessions in that case.
Right. So there's all these considerations to think about when you're running those tests. And again, coming back to the idea of do I download the resources or not is all about what are you looking to test, right? Because
I say you need to at least download them once, look at the logs, make sure that the cache settings are correct.
Right.
Because odds are, I've built a career off of most of these cache settings being incorrect.
But even yeah, but even again, it all comes down to what you're actually trying to test, I think. But one thing I think people need to consider is whether or not you're caching, depending on how many different virtual users you're going to be using and how many unique users who would be coming to the, simulating coming to the site for the first time. There's all those connections that the web servers have to be able to handle, right? You're not just testing load of the code executing through down to the database, but that first tier, your IIS server, your Apache server, whatever it might be on the front, has to handle all those connections to either fill the CDN's cache, to fill your browser's cache, whatever. So if that's not some part of some test, not every test, but maybe some test, you have to put that in there at some point because that's a big piece you're missing, a big section of load. Even if it is lightweight load, there's still connections, there's still, thread pools, there's still all this other kind of stuff going on that has to serve this stuff and make it happen.
Absolutely. And one layer we didn't talk about is an external web cache like Varnish or Squid. And I would refer your listeners to go and look up Varnish and Squid as caches and just use the context for the show to read through what those tools do.
I'm going to have to do that myself.
And they should have a pretty good understanding.
Yeah, I just heard Mark talking about those today, about possibility. There's a discussion about corporate enterprise applications, now that everyone's working from home with VPNs.
Oh, sure. Squid.
Using Squid or Varnish
I actually need Squid at my house.
Yeah, I need to look into what that is.
As a web proxy. Yeah.
This sounds like a good question, mate. What is a Varnish and Squid server? Brian asks. We'll do this in another episode. It's a good follow-up. Could be you, could be anyone else, but we'll see. We'll see how the ratings are for this one, Jim. I'm kidding. You're killing my show, Jim. No, I'm kidding. Looking back at some of these ideas, right? I think, and this is where I look to you for some more expertise, but I think one of the things that you really have to look at, whether it's browser cache, CDN, web server, Memcache, query cache, or hitting directly from the database, the most important thing before figuring out how to set up your test is to look at what happens in what data is accessed in production. Are users hitting, like let's say you have 1,000 different pages on your site. Are users hitting 50 of those pages 90% of the time? And then random ones, the other 10%? That's how you design your load test then. That's how you're going to be able to test these properly. Yeah.
Some of the cache exercise desires run counter to each other. For instance, on the CDN tier, you'd want like a 90% cache hit rate.
Yeah.
But when you get to your database tier, maybe you only want a 5 to 10% cache rate. And that goes to the point of each of these tiers is caching something different. For instance, on the web tier, it's caching static elements, images, JavaScript files, style sheets, things of that nature. And then when you get to your data that's actually being passed all the way back to database, that's where it's much more dynamic and where you have a much smaller cache hit ratio.
Right.
But you have that caching effect all the way through the system. And it's really interesting, the different hit ratios at different tiers that you want to exercise.
Yeah. And that then asks the Deer performance tester or the designer to talk to the different teams in the different systems to find out what caching strategies are employed in the different layers of the application, and how they expect, or can they find out how those are actually leveraged in the real world, and maybe what some tests of it being broken might want to be applied, executed. But this is how you get to know your developers, your DBAs, and how your system is set up so that you can create a more accurate test. That's one fun story I always bring up is, again, going back to WebMD, we had this pretty big release come through, and all the response times of all the pages increased by about 40%. And, this is good old waterfall days, and I was putting my foot down as the champion load tester, being like, 40%, decrease in, 40% increase in response time. This is where I'm going to stop this release and blah, blah, blah. And finally, we're looking at it, and the developers are scratching their head, and they're like, I don't understand this. We just introduced a caching layer. Like, this shouldn't be happening. It should be getting faster. And, one thing I've experienced, and I think almost anyone in load or in performance has experienced, is, the developer saying it must be your test, right? How many times if they always want to blame your test, right?
Yes. My baby is not ugly. Yeah. You need glasses.
Well, in this case, and again, I was pretty far into my performance testing career, but when I first got there, when I said, well, what data do we hit? Well, the main architect gave me these queries to run against the database to pull all the different page types. And here's this page. This will pull you 10,000, maybe there's 100,000 of these pages. This will pull you 10,000 of them. Great. I'd load those 10,000 into a data file, hit random, right? And once we started looking at the idea that they put cache, they're like, well, how are you hitting the pages? I'm like, well, just have them all in there and it randomly hits them. It's like, so each page is hit maybe once during the test. I'm like, yeah, probably statistically. They're like, that's not how it works in production. We have like all these pages are hit like, home page. There's a very repeatable pattern of which pages are being hit. So if you're hitting them all randomly, you're never going to touch that cache, which again, they didn't have the cache before. So it didn't matter so much because none of this stuff was cached. But now that it was introduced, there was a breakdown in the communication. Nobody said to me, hey, we're introducing a caching layer in this next release. Are your tests set up to test that properly? And how are you doing that? And I didn't know enough to look in or even ask about these things.
All you have to do is adjust your data at that point to have a higher frequency of some same pages or same elements. And there you go. You're exercising the cache.
Yeah. So these are the things that I think it's important to talk to the people to find out all of these things and always be asking these kinds of questions. What about you, James? Anything that you feel that we might have missed or that you wanted to get in about caches or testing before we wrap up here?
No, just keep the original concept in mind of you want data in the least costly location to access it. Mm-hmm. And network is more expensive than disk. Disk is more expensive than memory. And core memory is more expensive than on-die memory for the CPU. And if you just keep those relative weights in mind, and then you look at where caching is in effect in the system, it'll start to make sense of what you're reducing the cost of.
Yeah.
You're reducing the cost of a longer network. You're reducing the cost of going to disk. You're reducing the cost of going off CPU to get something from main memory, all of those types of things.
Excellent. Well, James, thank you very, very much for being the guest today. And thank you, everybody, for listening. Tricia, thank you for sending the question to us. We hope you all learned a little bit from the response. And as I always say, I sure did. And I never lie about that. All right. A big thanks to James Pulley for helping with today's question. Make sure you check out News of the Damned. It's a pretty good show. Pretty good. No, it's a really good show. A lot of great things you can learn from it from there. A lot of awesome mistakes that people make that we get to improve upon. And if you have any questions for Ask Perf Bytes, please send your question to ask@perfbytes.com, or you can follow me on Twitter at AskPerfBytes or at Emperor Wilson. You can always subscribe to Ask Perf Bytes on Apple Podcasts, Breaker, Stitcher, Overcast, TuneIn, etc. You can also leave a voicemail, and I know I always say this shocked, but James, you know about this, right? The voicemail?
Yeah, it's 77 load perf.
Right, that's 775-623-7373. I keep on meaning to call it and leave silly messages, but I always forget to do that. But it's just fun that we have a phone number in this day and age. If you like performance podcasts, also make sure to check out Pure Performance, which I co-host with Andy Grabner. James, do you have any other performance or technology-related podcasts that you like and would like to suggest to listeners?
Of course, all of the Perf Bites family of podcasts. We have your show, Brian, Ask at perfbites.com. We have Perf Bites Espanol with Leandro Melendez. And then, of course, we have our core show with Mr. Mark Tomlinson. That's the Perf Bites podcast. So please tune in to all of our podcasts, and anything Monty Python related, I'll probably listen to that too.
All right, perfect. I love Monty Python. Cheers, and as always, best of luck, everybody, in your performance efforts. I'm Brian Wilson. Thank you for listening.
I'm James Pulley, and this show has been cached.